All right, what is this pink distance right here? It's 5. Label it on your triangle too, please. Okay. What is this green distance right here? Okay. It's 7. So if I want to figure out the hypotenuse, what can we use? Five squared plus 7 squared equals x squared. We have a right triangle. Okay. We can count vertically. We can count horizontally. We have a right triangle. So to find the hypotenuse, we've set up the Pythagorean theorem. Okay. So we have 25 plus 49 is x squared. Jacob, what did you decide 25 plus 49 was? 74? 74. 74. So then, if we want to undo the square, we need to square root both sides. So our answer is the square root of 74. Is 74 a perfect square? It is not. So our answer is the square root of 74. So what did we find? We found that the hypotenuse of this triangle is the square root of 74. Okay. Now what that means is if we measure the distance from B to C, then it's the square root of 74. Okay. Now, I want you to look a little bit closer at this picture. Without counting, looking at this picture, how else could we get 5? Okay, so do you see how this is 7 and 2, and when we subtract them, we get 5? Okay, what about here with 7? 8 minus 1 is 7. Okay, I mean, potato. Okay. Okay, so this is going to come into play here in a moment. But what I want you to do right now is turn to page 19. I know it. Keep the yellow out. Keep the yellow out. Okay. Hey, Tony. So we're on page 19. Okay. Now, our goal today is to find the distance between 2 points. Tony, what's our goal? To find the distance between 2 points. Okay. Now, eventually I'm going to give you a formula and we'll talk about why. But when I'm talking about the distance, if I'm asking you to find the distance, I'm asking you how far is coordinate 1 from coordinate 2. Okay, if I measure it, how far apart are they? Okay, now, since we're talking about 2 different coordinates, do you see how I have cute little 1s right here and cute little 2s right here? That's just telling me, hey, this is the first coordinate. Hey, this is the second coordinate. What?
Why is there 1, 2, 3?
Those aren't commas. Okay, I just said this, Cash. These are cute little 1s saying that, hey, this is the first quadrant coordinate. These are cute little 2s saying, hey, this is the second coordinate.
Oh, so a cube?
No 2s. I was just being silly with my words. I'm sorry. They're just small numbers called subscripts telling us like, hey, this is the first. Hey, this is the second. Okay. Now, let's look right here at number 1. Okay. I'm asking you to find the distance between these 2 points. Now, we just talked about, can we take a slanted line and just count the distance? No, but what can we draw? We can draw a triangle. So we can count up and down and we can count side to side. All right. So I'm going to start drawing up and down and you tell me where I should stop.
Wait, what did it say? How far is X and Y from what?
When should I stop?
Stop.
Right there? Okay. How did you know that's where I should stop?
Because it's with other dot.
Just telling me how it is. All right. That's where this dot is. So now I'm going to go side to side. Thank you. Thank you. Tony, were you asking me what we wrote down up here?
How far is X, Y from?
Okay. Caesar, you good? Okay. Caesar, can you help me though? I'm not very good at counting today. My head's just not in the right place. Could you tell me how long this side is right here? Caesar, can you tell me how long this is right here? This right here? 7? Okay, so I'm gonna label it 7. Austin, what's this side? 6. Okay, so I don't doubt you. No. Caesar was doubting you, so I was just giving him some. What? And JV and reserve. Right. Okay.
Is that foundation? Reserve A is losing.
What? So if I count here, 1, 2, 3, 4, 5, 6, 7. Where? This is on the corner. It's not on the half, it's on the corner. Yeah, I'm sorry. Okay, so if I want to find this distance right here, we need to say 6 squared plus 7 squared equals x squared.
It's split. Yeah, square. That's what you have.
No, I know, but we're just doing down and over. We're not worrying about this. We're just worrying about down. I see what you mean, but I don't care about that. I'm just counting these down. Okay?
Stupid.
No, you're not. No, you're not. All right. What do we got, Kanaya?
So 6, is it 6 squared?
Yep.
Equals 36.
Okay, and Kanaya, when you add those together, what do we get? 85. Is Kanaya correct?
Yes. Yes.
Me too. All right. So now, what do we need to do? We need.
We gotta move the 2 to the X.
Okay. So, yeah.
And then we do X equals 85. X equals 80. Yeah.
Square root of 85. Is 85 a perfect square?
No.
No. So we're just gonna leave it irrational. Okay. Okay, I am going to give you just a little bit of time. I want you to draw the triangle in number 2. Okay, so what did we talk about, right? Go down until you, so up and down and side to side. So go down until you get to the next point and then go side to side. Whoa, girl, that's too far. We're on number 2 on the white, buddy. Okay, draw the triangle. Hey, Wes, how far do we need to go down? 1. And then we can go over how many? 9. All right. So find me the hypotenuse. Go. What do you mean? How did I get that?
Never mind. I got it. Is it cool?
It's just you.
It's just you. Wait, what's one, two?
One squared is 20.
No, you're asking me?
What's, is nine squared 81?
Two.
All right. Kaylee, what are you getting for an answer? Do you have an answer? Almost there. No, I didn't. Okay, Kaylee has the square root of 82. Because she took 1 squared plus 9 squared equals x squared. So she has 1 plus 81, giving her, Tony, 82. To undo the square root, we're going to square root both sides. And don't forget to keep the square root on the 82 since he's not a perfect square. No, that would be divided by 2, Stevie. I'm sorry. It's okay. It's okay.
Keep on going.
Do you know where to say that?
Are they?
I was being funny on that.
Where are you? Okay. Now, we're get what?
Why did they erase our predictions?
Yeah, why'd you erase cash?
I don't know.
Cause my prediction is there.
Okay, we're gonna skip number 3, and number 4 is gonna take us 2 seconds. What's cool about number 4?
It's square.
It already has the measurement for you. Do we need to draw a triangle if it's straight up and down? No. Can we count straight up and down? Yes. Kale says he counted 6. Nope, just 6. We counted 6, so we leave it at 6. We are wound up today.
Yeah, cause it almost Super Bowl.
Okay, so Kale, Cash, we start here and we say 1, 2, 3, 4, 5, 6. Since it's straight up and down, we don't have to draw a triangle.
Why would you draw a triangle?
No, because here we didn't. We can only count. We can only measure up and down or side to side. So that's why we had to draw a triangle. I can't count boxes here. I have to go down and then over. Okay. Now, I want you to look at number 5 through 8. Okay, there's too much talking right now. I'm usually pretty patient, but my patience are wearing. Okay. I want you,
Please, can I let you?
3 minutes, otherwise you'll stay after, okay?
What do you mean stay out there?
3 minutes, go. Okay, now,
So that off.
we don't have a graph here to draw a triangle, right? Okay, okay. I will start keeping track of how long the whole class will stay through passing period
Oh, no.
if we cannot focus.
Shoot. Every tape.
Yes. What?
When's the Super Bowl?
Sunday at 5:30. Okay. When we talked about this over here, we talked about, hey, we got 7 by subtracting the x's, and we got 5 by subtracting the y's, and then we use the Pythagorean theorem. So we have something that's called the distance formula that comes from the Pythagorean theorem. And this is what I want you to write down. I want you to write that the distance equals, okay? What happens with the Pythagorean theorem? We take something squared plus something squared,
Plus X.
and then it usually equals x squared. So when we get our answer, we have to square root it. Okay. So what we're going to do is we're going to take the second x minus the first x. And that's the first thing we're gonna square. We're gonna take the second y minus the first y, and that's the second thing we're gonna square. Okay, just like we talked about in that introduction. Okay, now sometimes this can be a lot to remember. So I have a little like formula sheet for you to fill in and use if you think it's going to help you. So I'm gonna give you this yellow piece of paper. And you can use this yellow piece of paper for notes and the homework if it helps you. Okay? So I'm gonna show you how to use it. Are you ready?
I wrote a
Okay.
pencil.
I don't, just stop.
Wait, fix on that.
I didn't say that you did. I'm just asking you to stop. Okay. So I want you to look at number 5. And what I want you to do is on number 5, write x1, y1 above 0, 0. And I want you to write x2, y2 above 6, 8. I'm curious with the noise level. Stop talking when I am. Okay, so I'm gonna first teach you how to use what I'm gonna call the cheat sheet, okay? So go to the yellow cheat sheet, and what we're gonna do is we're gonna put, okay. Just pick the first one, doesn't matter which side, they're all the same. Letter A is 0, 0, and letter B is 6, 8. Right here. Okay. So what's nice about this yellow sheet is it tells you exactly where to put the numbers. Do you see that this says x2? Okay. Well, this says x2. So I am going to take 6 and put it where x2 goes. Just reading a chart. Okay. Now, this says x1. Well, here's x1. So I'm going to take that number and put it here. Okay. You ready? This says y2. Where's y2? Okay, y2 is right here. So that number is going to go here. And then now I need y1, which I can find here. So here's where I'm going to put it. That's the hardest part. Putting the numbers where they go. Now we do simple calculations. Okay. Now we do, what is 6 minus 0? So 6 minus 0 is 6. So we're going to write that here. And 8 minus 0 is 8. We're going to write that here.
36 and
36 and 64. Do you agree with Tony?
I do.
Okay, Kanaya? Oh, so when we add it together.
It's not 100.
That is.
How was? Oh yeah.
Ooh, and Kanaya says 100 is a perfect square. So we can say that the square root of 100 is 10, and that is our answer. What 2? Like which two? No. We just write 10. No 2 in the corner. Okay. Okay. Now, some of you might really like the yellow sheet, and some of you, you might not care. Okay. So what I'm going to do is I'm going to go back to our notes sheet. Page 19. And we're going to look at number 6. I am going to do number 6 on page 19. You can choose whether you want to do it on page 19 or if you would like to do it on the yellow sheet. Okay, you decide. But I'm just going to put a reminder that our distance formula, and this is something I will always write on the board, is x2 minus x1 squared. No, that's an x. Plus y2 minus y1 squared. This is page 19. We haven't moved. We haven't moved. Okay. Now, you are either going to write your coordinates on the yellow page, or we need to label R is x1, y1, and S is x2, y2. Okay, so now what we're going to do, which number is x2?
3.
Good. So that's going to go here. Which number is x1? Okay, so that needs to go here. Which number is y2?
15.
Okay, so we're going to write 15 right here. And y1 is the only number we haven't used, which is 3. Okay, now here's where we need to be really careful. Do you remember back, one of the very first things we did in the whole year is we talked about how to add and subtract integers without a calculator. Still doing that. So 3 minus -2. What is it?
1.
Nope.
5.
It's 5. Because when we subtract, we're adding the opposite. So subtract means adding the opposite. So this is 5 squared. And what's 15 minus 3? 12.
How is it 12?
15 minus 3? Okay. So now, Kanaya, you're rocking your perfect squares today. What's 5 squared? See? Cash, what's 12 squared?
144.
Good. Okay. So now our last step is to add these two together. What happens when we add 25 and 144? 169. So our answer is the square root of 169. Do we leave it like that, or is that a perfect square? It is a perfect square, so our distance is really 13. Now, it's not going to be a perfect square every time. So if it's not a perfect square, you're just going to leave it as that irrational number. Okay.